All right. Oh, that noise. Okay, so we already know what's up with SOHCAHTOA, right? Oh, by the way, I hope you guys are having a good day. Isn't it so awesome that it's raining? Yeah. All right. I love it. I love it, love it, love it. So SOHCAHTOA, you guys are already pretty good with that. Then the cosecant is just a reciprocal sine, secant is a reciprocal cosine, cotangent is a reciprocal tan. That's not a big deal. And it says, let's chat about the 6 trigonometric properties with respect to the unit circle. So let's talk about that. So first, let's draw the first quadrant of the unit circle. I'm going to draw it right here. And I go something like this, 30, 45, 60. So this is 30 degrees, which is also the same thing as pi over 6. This is 45 degrees, which is also the same thing as pi over 4. And this is 60 degrees, which is the same thing as pi over 3. Here's 0 degrees and pi over 2, which is the same thing as 90 degrees. This coordinate here is 0, 1, and this coordinate down here is 1, 0. And then at pi over 6, the x value is larger than the y value, so that's square root of 3 over 2, comma 1 half. At pi over 4, or 45 degrees, the x and y are the same, so square root of 2 over 2, square root of 2 over 2. And at pi over 3, you just toggle the square root of 3 over 2, comma half, so this turns to 1 half, comma square root of 3 over 2. And hopefully it's getting borderline like etched into your brain because you've been doing this so much. So it just takes like 3 attempts really. After your third attempt, you start like really having this memorized. And then remember what we said, that the cosine theta is equal to your x value on the unit circle, sine theta is equal to your y value in the unit circle, and that tan theta is equal to y over x. This is always going to be true. It's just a ratio. So at 30 degrees, it's always going to be, so let's just focus on the 30-degree one. So if I were to, and it says all 6 of them, right? So I'm going to get all 6 of them. I'm going to write cosine 30 degrees, sine 30 degrees, tangent 30 degrees. Let's see, what else? Reciprocal cosine, secant 30 degrees, cosecant 30 degrees, and cotangent 30 degrees. All right. I haven't done anything crazy, guys. I just wrote cosine, sine, tan, secant, cosecant, cotangent, all of them at 30. So cosine at 30, cosine's the x value, or adjacent over hypotenuse. If you were to do a triangle right here at 30 degrees, remember that this is your theta here, or your 30 degrees here, and that the adjacent is horizontal displacement. So the horizontal displacement at 30 degrees, that's square root of 3 over 2, and that your vertical displacement is a half. The hypotenuse is 1. So cosine of 30. What is cosine of 30, guys? Yep, square root of 3 over 2. Done. Sine of 30. 1 half. Cabastes. Cabastes is Spanish for done. I think I used it correctly. Tan of 30. Y over x. So you can, if you want, write 1 half over square root of 3 over 2. And I'll say okay. There's a better answer. 1 over square root of 3. And there's a better answer than that. Square root of 3 over 3. They're all the same. Cool? All right, secant of 30 degrees. Secant's the reciprocal of cosine. You can write it like this. 2 over square root of 3. Child, if you didn't rationalize the denominator, it's okay. If they don't ask you to do that, you don't have to do that. You could also say 2 square root of 3 over 3, but you don't have to. Are we okay with that, guys? Okay. Cosecant of 30 degrees, what's the reciprocal of half? That's it. 2. And then cotangent of 30, yes, you can write square root of 3 over 2 divided by half, but the better answer is just square root of 3. Did I go too fast, or are we okay? We okay? Yeah, guys, ask me because I can't read mine. Sometimes I can read faces, but not always. No. Okay, nothing happened. I don't think so. It's because I just bought it. I don't want to break it yet, you know? Okay. We're good. Let's go to the next one. It says, example one, find the exact value of the six random functions of 60 degrees. Okay, I'm going to reference 60 degrees. So here is 60 degrees. And at that coordinate, that is 1/2 comma square root of 3 over 2. And let's see, what do I need? I need sine 60 degrees, cosine 60 degrees, tan 60 degrees, cosecant 60 degrees, secant 60 degrees, and cotangent 60 degrees. All right, sine 60. Sine 60 is square root of 3 over 2. Cosine 60, 1/2. Tan 60, y divided by x, square root of 3 over 2 divided by 1/2. I just get square root of 3. We're okay with that? Okay, cosecant is the reciprocal of sine. 2 over square root of 3, or 2 square root of 3 over 3. Must replace it already. I'm looking at the little tip. When it fell, it hit like this, and the little tip is slightly no longer curved. You know what I mean? It's a little flat from the hit. So that means I need to buy tips now. See how sensitive these things are, man? One drop. All it took was one drop. Secant of 60 degrees. What's the reciprocal of half? 2. And then cotangent, you can write it as 1/2 over square root of 3 over 2, or you can write it as 1 over square root of 3, or you can write it as square root of 3 over 3. All of them are the same. Sorry, guys, I'll keep looking at this pencil. I'm just wondering if I should just buy another one. All right, here we go. Evaluate the sixth trigonometric for an angle of 180 degrees. So I want to do the same thing, guys. Sine of 180 degrees, cosine of 180 degrees, tan of 180 degrees, and then secant of 180 degrees, and then cosecant of 180 degrees, and then finally cotangent of 180 degrees. I didn't go in order. In the unit circle, 180 degrees is right there. That is -1, 0. Sine of 180. Sine is the y values. The y value of 180 degrees is 0. Cosine of 180. Cosine of 180 is the x value, -1. Tangent of 180. Y divided by x. So 0 divided by -1, that is 0. The other way around is not a thing, right? Secant of 180, secant is a reciprocal of cosine, so that's still going to be -1. Cosecant is a reciprocal of sine, that's going to be undefined. And then cotangent of 180 degrees, that again is undefined. 0 over -1, I mean, -1 over 0 is not a thing, guys. So there it is. What do you guys think? Nothing crazy? Yeah, that's it, guys. Yes. Oh, because the reciprocal of -1 is itself. You can say it like that's like that. So 1 divided by -1 is still -1. You know what I mean? It's a good question, Vega. Good question. I'm just testing my little digitizer here. It still works. Okay. Don't freak out. This is not that bad. It says the terminal side of an angle theta contains a point -5, 2. Find exact values of the 6 trigonometric functions of theta. Use radicals, no decimals. All right. So this is in quadrant 2. So I'm going to exaggerate quadrant 2. So here it is, me exaggerating quadrant 2. -5, 2, put a point. And from the origin, make a right triangle. It's always going to be perpendicular to the x-axis. This distance is -5. The vertical displacement is 2. I need to know what the hypotenuse is. I'm going to use the reference angle to help me out. The real angle is this one, but I'm using the reference angle to help me out. Are we okay so far, guys? I haven't done anything crazy, right? All right, here we go. I need the hypotenuse. To get the hypotenuse, I'll just do Pythagorean theorem. -5 squared plus 2 squared equals, and what do you want to call that? R? R squared. So to get R, I'm going to take the square root. And if it's not a perfect square root, leave it alone. I don't think this one is. -5 squared is 25. 2 squared is 4. And that's going to be the square root of 29. So I'm going to leave it at square root of 29. The hypotenuse will always be positive. Put that in your notes. Hypotenuse is always positive. All right, here we go. Sine, cosine, tangent, and then cosecant, secant, and cotangent. All right. Use the reference angle to help you guys. And I'm going to slow down. Sine, opposite of hypotenuse. Use the reference to help you. What's opposite? 2. And then the hypotenuse is? Yeah, leave it at square root of 29. Because it's not a perfect square root. All right, cosine. What's adjacent? Use the reference to help you out. -5, and then the hypotenuse? There it is. See? Say it again. No, unless they tell you. Delta math is going to tell you to rationalize. I am perfectly fine with that. Cool or not cool? Tangent. What's tangent, guys? Not everyone at the same time. Yeah, 2 over -5. 2 over -5. All right, cosecant. Cosecant's a reciprocal of sine, so just write square root of 29 over 2. What about secant? The reciprocal of? You can also put the negative in the front. And then cotangent. There it is. That's all it is, guys. Good job. Good job. Cool or not cool? I have no more passes, miss. Oh, look, I only have 3 more. Can you tell the teacher to give you a pass?
He's a sub. I don't think he has.
Tell the sub just to let you go. Okay.
For one, can one be for both things?
1 for all of them.
Okay.
We only have 2 left.
Okay.
All right. Next one. If an angle theta terminates in quadrant 4 and cosine is 3/5, find the exact values of the other 5 trig functions. Okay, you're in quadrant 4, so I'm going to exaggerate quadrant 4. And always start from the origin, and it's always perpendicular to the x-axis. And I'm going to write not to scale. So this is the angle that we're actually looking at. It's this one here. But we're going to use this one to help us out. So 3, adjacent, hypotenuse, 5. It's a 3, 4, 5 triangle, but if you did not see that, or if you did not see it, you would go 3 squared plus y squared equals 5 squared. Then move that guy to the other side. Y squared equals 5 squared minus 3 squared. Y equals the square root of 25. 5 squared is 25. 3 squared is 9. And then the square root of 16, which is 4. And I'll wait for you guys to catch up. Nah, you don't need it. I'm in quadrant 4. So in quadrant 4, the y value is, starts with an n, negative. So I'm going to write -4. Do you guys see how we did it? All right, I'm going to use the reference to help me out. I'm going to write sine theta, cosine theta, tan theta, cosecant theta, secant theta, cotangent theta. Use the reference to help you out. Sine, opposite over hypotenuse. What do I write? -4/5. Cosine, adjacent over hypotenuse. So I guess that was given. 3/5. Tangent, opposite over adjacent. Cosecant, what's the reciprocal of sine? Secant, what's the reciprocal of cosine? And then cotangent. There it is. How do we feel, guys? Not bad, right? Yeah, that's it. We just got one last question, guys. Look at you guys speeding through this. Oh, did you guys, everyone get this? Okay. All right, last one. If an angle theta terminates in quadrant 1 and cosecant is 13/12, find the exact values of the other 5 trig functions. Okay, exaggerate quadrant 1. So here I am, exaggerating quadrant 1. And cosecant, the reciprocal cosecant is sine. So sine of that angle is 12/13. That is a special right triangle, not to scale. Not to scale. Here's your theta and sine. So this is 12, this is 13. In case you don't know what x is, I'm going to write x squared plus 12 squared equals 13 squared. Move the 12 squared to the other side. X squared equals 13 squared minus 12 squared. Square root. X equals the square root of 13 squared minus 12 squared. So let's see. 169 minus 144, 44, 54, 64, 20. Okay, so I have square root of 25, which is 5. You didn't have to do that. If you already saw, if you remember from geometry, that's just a 5, 12, 13, then you're good. Okay. I'm going to go ahead and just write sine, cosine, tangent, and I'm going to write cosecant, secant, cotangent. Sine was kind of already given to me, not immediately, but it was kind of given. See, 12/13. Cosine is what? Yeah, 5/13. Not everyone at the same time. What's tangent? 12/5. Cosecant was given. Secant the reciprocal of cosine. And then finally cotangent. Perfect. Did I give you guys oh yeah, Vega did, right? You gave it to him? Okay, so check out that one handout. I'm not going to do them all, guys. I'm just going to do some of the odd ones. So you guys decide. Number 1 or number 3? Number 3? Okay, so number 3. It says -5, -7. So I'm going to exaggerate quadrant 3. So here I am exaggerating quadrant 3, not to scale. I'm going to go -5, -7. I'll put a point and go from the origin to that point, and then draw up a perpendicular to the x-axis. This is actually, the actual angle is this one, but you're going to use the reference to help yourselves out, theta r. So that means this is -5, this is -7. I'm going to go square root -5 squared plus -7 squared. Let's see, 5 squared is 25, 7 squared is 49, 50 and 25 would have been 75. So is this the square root of 74? I think so. It doesn't break down. Leave it alone. Is the hypotenuse ever negative? No, never, never, never. I don't know why I said never like that. Sorry. All right, here we go. I'm going to come over here. I'm going to write cosine theta, sine theta, tan theta, and on the other side I'm going to write secant theta, cosecant theta, cotangent theta. If I could have written it all in one, maybe I had, you know what? Maybe I have enough space. Maybe I have enough space. I could write it down here. Let's see. Secant theta, cosecant theta, cotangent theta. Yeah, I got enough space. All right, cosine. Adjacent over hypotenuse. What am I going to write? Yeah, perfect. Negative 5 over square root of 74. What do I write for sine? Perfect. Let the reference angle help you out to decide what's opposite. What am I going to write for tangent? The other way around. Opposite over adjacent. Negative 7 over negative 5. Negative divided by negative? Positive. Don't worry. If you would have written a negative over negative, I would have counted it correct anyways. But you always want to have just simplify it to the simplest form. Secant. The reciprocal of which one? Cosine. So you're going to write what? Square root of 74 over negative 5. You can put the negative in the front. Cosecant. You're going to write the reciprocal of sine. So square root of 74 over negative 5. Sorry, it's kind of tight here. Yes. What are you talking about? I'm kidding. I knew I made a mistake there. Cotangent. There you go. Cool or not cool, guys? Yeah, it's not the most exciting. I mean, I guess you could always hype anything up, right? But come on, let's go. Okay, what's up?
So if we were like writing the secret or cosine or cotangent, do we like the reciprocal like the simplified version, or do we do?
If they don't tell you specifics to simplify it, you can just leave it. On the exam, we'll be very explicit. Like we'll tell you what we want. You know what I mean? On Delta, it'll be very explicit too. All right, go to number 7. So number 7 says secant theta is 4, and you're in quadrant 4. So let's exaggerate quadrant 4. So here I am exaggerating quadrant 4, not to scale. And here's my angle. Perpendicular to the x-axis, my right triangle. This is your real angle, this guy right here. But we're going to use this guy, the reference, to help us out. Secant is 4, so if secant is 4, that means that cosine theta is a 1/4. 1 up here, 4 down there. Or 4 for that. That's like your R, right? The hypotenuse is like your R of the circle. Radius 4. How do I get that leg, the y leg, the vertical displacement? You're going to go, you can say, I guess you can go 1 squared plus y squared equals 4 squared. And then move that 1 squared to the right. Y squared equals 4 squared minus 1 squared. Y equals the square root of 16 minus 1, which is the square root of 15. Leave it alone. So this guy right here is the square root of 15, but I'm in quadrant 4. So in quadrant 4, what is negative? Ah, dang, I said the answer. It's negative, right? The negative. Okay. This is negative square root of 15 because you're in quadrant 4. Because it's like a radius. The hypotenuse is never negative. Did you write that down in your notes? Because this is like your hypotenuse. Eventually, when we start doing polar, it is possible to have a negative radius, but it's not what you think it is at the moment. So unless you know about polar, has anyone here covered polar? Maybe like in the summer camp or something? There's usually one. No? Okay. So R is always positive unless we're doing polar, but it's not what you think it means. You'll see when we get there. Are we okay right now, guys? All right, we're done. Well, almost done. We just got to give all the values that we want, right? I'm going to put it up here because I have a lot of space up here. I'm going to write cosine theta, sine theta, tan theta, and I'm going to write secant theta, cosecant theta, and cotangent theta. All right, secant is 4, so that was given. Because secant is 4, my cosine is 1/4. That's kind of given. You can also get it from your reference angle. Sine, negative square root of 15 over 4. Now 15 does not break down. 5 times 3, end of the breakdown. Tangent, opposite over adjacent, negative square root of 15 divided by 1, so I can just leave it as negative square root of 15. Cosecant, cosecant is the reciprocal of sine. You can write this as 4 over negative square root of 15. And then finally cotangent. Let me see if I can, I'm going to remove the not to scale so I can write this here and not get confused. The cotangent one, let me see if I can, the cotangent is going to be, let's see, 1 over negative square root of 15, or negative square root of 15 over 15. Okay. How do we feel, guys? Oh, what's up? Oh, yeah. All right, last ones. This one's in notes. So that's like a gift. The other one, number 13, is also in notes. So there's no way you can get those two questions wrong because you already have them, right? So the only one is negative 315. We'll do that one together. Negative 315 is in quadrant 1 when you go like this. F negative 315 degrees. This coordinate, if you think about it, that coordinate is square root of 2 over 2, square root of 2 over 2. Don't worry, guys, we're almost done. All right, we got it. So I'm going to write cosine 315, sine 315, tan 315. Let's see, secant 315, cosecant 315, and cotangent 315. We're practically done, guys. What's cosine of 315? Yeah, what's sine of 315? What's tan? Square root of 2 over 2 divided by square root of 2 over 2, which is the same thing as 1. I would have counted it right, square root of 2 over 2 over square root of 2 over 2, but the best answer is 1. Secant of 315, just take the reciprocal of cosine, 2 over square root of 2, or you could just say square root of 2, right? 2 square root of 2 over 2. 2's cancel out. Cosecant, again, same thing, 2 over square root of 2. And then cotangent is going to be 1. How do we feel, guys? Nothing crazy, right? All right, guys, that's it. I think you are fast enough to get this done in class, but if it creates anxiety, you can turn it in tomorrow. But I would prefer today. So let's just make sure that we're working on this. You can work together, and that's it. We're done. Yay! No Delta Math today. I would like a visual, unless you don't like the visuals.